Solar energy passes through the atmosphere before reaching the Earth. During this journey, some of the radiation is reflected and sent back into space. Another part is scattered in the atmosphere due to its interaction with the gases that make up the atmosphere. The part of the radiation which is scattered in the atmosphere is in the infrared range and manifests itself as heat. Finally, the remaining radiation reaches the Earth's surface. In order to estimate the amount of this energy that the Earth receives, three quantities are used. Irradiance is the power received per unit area on Earth. It is represented by EE and is measured in watts per square meter. Just outside of the Earth's atmosphere, the irradiance is 1368 watts per square meter. This is called the solar constant. After passing through all layers of the atmosphere, the irradiance decreases. So, at sea level at noon, the irradiance is about 1000 watts per square meter. Radiant exposure is the amount of solar energy received per unit area. It is measured in watt-hours per square meter or in joules per square meter. The duration of sun exposure, written as delta T, is measured in hours or seconds. It is generally between 9 a.m. and 6 p.m. Hence, the radiant exposure is the product of the irradiance and the amount of time a surface has been exposed to the sun. When solar energy finally reaches the Earth's surface, it can be used indirectly or directly. In the first case, the radiation is concentrated in one spot. This is the principle behind concentrated solar power. The solar energy is transformed into thermal energy, which warms a heat-transporting liquid, often water. After being transformed under pressure into a gas, it turns a turbine to power a generator. This mechanical energy is then converted into electrical energy. We can also use photovoltaic cells to directly transform solar energy into electrical energy. Photovoltaic cells convert the energy of photons, which are the particles that make up light, into electricity. The energy of a photon, noted E photon, is calculated by multiplying Planck's constant h by the frequency of radiation. The part of solar energy caught by the Earth and estimated in terms of power, quantity, and duration of sun exposure can be used directly or indirectly to create electrical energy.